So here's quiz 6. I'm just going to do each one of the problems. So the first problem, you had to find the volume of the solid between the xy plane and this function f of xy equals x sine y over this rectangular region. I'm not going to draw anything. I do have Mathematica open, but I'm not going to show you that. But basically the idea is the base of this solid is this rectangular region, and the top of the solid looks like some kind of wiggly top, x times sine y. And you like to find the volume using double integrals. So step 1 is always to draw the picture. Draw region. And if I draw that region, what it looks like is from x, I get 1 to 3. Here's 1 to 3, and we're going to use a different color for the lines. And y goes from 0 to pi over 2, which is somewhere up here. So that's like the cut point. And if I draw that up, here's my x equals 1 to x equals 3. And here's my y equals 0 to y equals pi over 2. So it's this region right here. So now I'm ready to set up the integrals. I'm less fanciful of the pi over 3, so I'm going to start with just my x's. X equals 1 to x equals 3. And then my y would be 0 to y equals pi over 2. And my f of xy was x sine of y. And here goes dx, because the x's here have to match. And next goes dy. Now I'm ready to execute this. So what I'm going to do is actually I'm going to erase my little arrows that I have here and copy this to the next page. As usual, something else has come off, but here we go. Let's copy this out. Copy, and then run it to the next page. So we integrate first with respect to x. So I'm going to take my inner integral, and usually I don't do this like this level in class, but I want you to see where I got everything on this. So if I integrate the inner integral, I get x squared over 2 sine y from x equals 1 to x equals 3. And now I plug in my 3 and 1. So this inner integral, by the fundamental theorem of calculus, evaluates up to be 9/2 sine y minus 1/2 sine y. Now I do this again, my outer integral. It's going to look like the integral from y equals 0 to y equals pi over 2 of 9/2 sine y minus 1/2 sine y dy. And I guess I could have just written this as 8/2 sine y, which is really 4 sine y. So this really is 4 sine y. So unlike you, unless you're using an iPad, I'm just going to replace this with a 4 sine y. Oh, I think I said pi over 3, but it's really pi over 2. Y equals pi over 2. And it's going to be 9/2 minus 1/2 is 8/2, and that's 4 sine y dy. And then the antiderivative of sine is minus cosine. And y is from 0 to y equals pi over 2. How do I know it's minus? Well, I think of the derivative of sine is cosine. The derivative of cosine is minus sine. So I have to offset the antiderivative with the minus sign. That's kind of how I remember it. And so when I plug in these values, I get cosine at pi over 2 minus that. And cosine at pi over 2 is 0. So it drops out. and cosine at 0 is 1. So I just get a 4. There we go. That's number 1. We'll head to number 2. With number 2, I also have a counterexample of why putting in r equals -1 and r equals -4 is actually wrong.